In this video, we're going now to conduct hypothesis testing using the one-sample t-test. So, let's have this problem. A phone company claims its products have a power off time of at most 7 seconds. You test this statement by drawing a random sample of 25 phones manufactured by this company. Given that the following sample data, this one, and at 0.10 level of significance, is there sufficient evidence to disprove the initial claim of the company? So, first, we have to figure out if this is one sample t-test or we can actually do one population z-test here. Remember that it will be one sample t-test and not one population z-test if n is less than 30 and it's not normally distributed. So, here at our problem, it says that we have a sample of 25 phones, and we know that 25 is less than 30. Now, the problem does not say that it is normally distributed. Therefore, the assumption is it is not normally distributed. Because if a variable is normally distributed, it has to be explicitly stated. But since it's not, therefore, the default assumption is that it is not normally distributed. And since we have 25 is less than 30, therefore we shall use one sample t-test. So now that we know we will use one sample t-test, we shall now do our steps in hypothesis testing. So first, as always, our step 1 is to determine what is our HO and what is our HA. So, like what we do before, we first look at our claim. So it says here, a phone company claims, here is our Q, that its products have a power of time of at most 7 seconds. In the language of mathematics, at most is less than or equal to. So at most 7 seconds. Since we do not have this, we will just have this one. So the claim is that the products have a power of time of at most or less than 7 seconds. Therefore, since it's less than here, it's not the null, but the claim is for our alternative hypothesis. So our mean is less than 7. And for the null hypothesis, we have the mean is equal to 7. And since this is our alternative hypothesis, we know that this should be one tail, lower tail. So there we go. So this is now our step 1. Let's now go to our step 2. Maybe I will write it here. Step 2. In step 2, we will now use Excel for our computation. So, like what we do before, we go to data analysis. There we go. Let's just put it here. And this time, so here we can look at 3 t-tests that is shown by Excel. We have our t-test paired 2 sample means, t-test 2 paired sample assuming equal variances, and t-test 2 sample assuming unequal variances. For our one sample t-test, we will select the last one. So we shall have this one. And here you go. So we have, these are the things that we would need to go to. So similar to what we had before, we have your variable 1 and your variable 2. So for variable 1, it would be the variable given to us, these data rather. So we will have the power of time. So we shall select them. All the way down there. There you go. And then, for variable 2, there is none. So again, we have to apply what we have as our dummy variable. So before we input that here, Let's cancel that first, and we have to input our dummy variable, just like one population z-test. But in this case, we have to put at least 2 zeros here. Let's see that up close. So there you go. As you can see, we input the dummy variable and then we have 2 zeros as input. Sorry about the scribbles because we needed that. So here's our dummy variable with our 2 zeros there. So now we can return to our data analysis, t-test2 sample, and here we go. So again, we select our variable 1, this one here, our variable 2 as our dummy variable, our hypothesized mean difference is this one, the 7 seconds, so we will put here 7. Since we have labels here, I will check labels, then the output range. I want it here where I placed step 2. Here you go. So there, once you check everything, we can now click OK. So there you go. We have already our table. So now we have the step 2 of our hypothesis test, which is computing the values that we would need. In the next video, we're going to continue with step 4 of our hypothesis test.